Howdy there, Internet students. It's Mr. Hermanson again. This is some of the problems you had with the 11.7 assignment. It seems like a few people missed number 2 here, so let's talk about that one. The volume of two similar containers, the volumes, are 115 and 67. So the ratio of the volumes is 115 over 67. The surface area of the smaller container is 108. What is the surface area of the larger container? So what we would need is, this is the ratio of the volumes. We need the ratio of the surface areas in order to find that. Okay, now if you take the cube root of these ratios of the volumes, you'll get the scale factor. So we're going to do the cube root of 115 over the cube root of 67. Okay, now that's the scale factor. Now you need to square that for the ratio of the areas. Ratio of areas will be this squared. So I'm just going to leave it like this for now. Then I'm going to square it to get the ratio of the areas. Now I'm going to use that in my proportion. It says the surface area of the smaller container is 108. I have the smaller one on the bottom here. So I'm going to put 108 down here. And then in my calculator, I'm going to do this times this, cross multiply, and divided by this. All right. And I think you could do that now. Next one I'm going to go over is number 15. It says the surface area of two similar figures are given. The volume of the larger figure is given. Find the volume of the smaller. All right. So what we're going to do here is we're going to find the ratio of the surface areas. And it doesn't hurt to simplify that fraction. And that equals 4/9. Now that is the ratio of the areas. So the scale factor will be the square root of those. So let's take the square root of each of those, and then we get 2 over 3. That is the ratio. That is the scale factor. Now remember that the volume factor is those numbers cubed. We're going to cube both of those, and that gives me 8 over 27. And I'm going to use that in my proportion. But it says that the volume of the larger figure is given, so let's put that down here. And then we're just going to do our proportion there. I'll let you finish that one out. And then we'll move on to number 19. The volumes of two similar figures are given. Now this time we're given the volumes. So remember now this is the ratio of the volumes. And if we take the cube root of those, we will get the scale factor. So that's 3 over 4. Now if we square those, that'll give me the ratio of the areas, which is 9 over 16, and we're going to use that in our proportion. It says the surface area of the smaller figure is given, so let's put that up there. Throw an X there. Find the answer. All right, and number 22 seemed to be a problem. It says a cylinder with 4-inch diameter and 6-inch height holds a pound of oatmeal. How much oatmeal will a similar 10-inch high cylinder hold? So the scale factor would be the height to the height, which would be 6/10 or 3/5. Now, when we are filling it with oatmeal, we're talking about the ratio of the volumes. And we need to cube those numbers to get the ratio of the volume. So that would be 3 cubed over 5 cubed, which is 9 over 125. All right. And it says that we get 1 pound in the 4 by 6, and we need to, so that would be 16 ounces in the smaller one. So let's put that up here. And it says to the nearest ounce, so that's why I did 16 ounces there. So anyway, there's your proportion. That should get you the right answer. All right, and let's look at one more, number 27. The volume of a spherical balloon with a radius of 3.1 is about 125. Estimate the volume of a similar balloon with a radius of 6.2. So you can see that the radius is half, right? So the scale factor is 1 to 2. So the ratio of the volumes, which is what you would have for the air, would be 1 cubed over 2 cubed, which is 1 to 8. And it says the volume of the smaller one is 125. So let's put that on top, put X on the bottom, solve that proportion, and you'll be good. I think it comes out to 1,000. Anyway, all right, I hope you find that helpful. We'll talk to you soon.